Hello, welcome everyone to season 3 of the Virtual Ninja Show. My name is Heike Ritter and I will be your host. I have again exciting experts with me on the show. Today is episode number 1 and I have Paul with me. Before I hand over to Paul, it's a complex topic, so bear with me. I might ask weird questions because I'm totally new to this topic. And also the name of the episode is a little bit weird. So we will ask Paul to introduce himself and also please demystify that title that you gave us.
Thank you for having me, Heike. My name's Paul Newell. I am a product manager for the Microsoft Defender for Office 365 Customer Experience Engineering team. And yes, it is a fairly complex topic. So if I glance down to remember what my title is or what it is that I'm actually talking about, please don't hold it against me. I wanted to kind of build on the experience of the Ninja Show, and now we're going to talk about slicing out some of our unnecessary overrides and how to master the art of email authentication.
I love it. Thank you so much. And just for everyone, internally, we sometimes use MDO. So in case we are mentioning it here, it's not an official abbreviation, but we are just totally used to it. So sorry, usually it's Microsoft Defender for Office 365 or Defender for Office 365, but sometimes it slips out of us. So I think the translation also for the title is we want to have a look at false positives and false negatives when it comes to emails that are arriving or not arriving into our mailbox. Is that right?
That's correct. So, Heike, have you ever had an experience where in your inbox you see a message and you think, that shouldn't be there. This does not look right. This should not be in my mailbox.
I'm thinking a lot of things when I see all the things in my inbox, but yes, I also had that one. Yes.
Okay.
What is it?
Well, that's a false negative. So anytime a bad message ends up in your mailbox, spam, malware, phish, anything that is a concern, that is what we call a false negative. And
so false negative because it's a bad email and it should not have arrived into my inbox.
That is correct.
Okay.
That is correct. And then the opposite, have you ever experienced a time where you see a message in your junk folder and you think, oh, that's a legit message. That's a flyer from Aldi or Lidl that I would have expected. Or maybe there's a message that you were expecting from someone that it was either in the junk or in quarantine. Have you ever experienced that?
Yes, I think this is actually the only reason I'm looking through the emails in my junk folder. Otherwise, I would just delete it. But yes, it happens that actually emails that I'm waiting for are sitting there.
Sure.
And
sure.
That's now what?
Well, that's a false positive. So we looked at that message and we thought that there was something about that message that should not have been delivered to your inbox. We either thought it was junk, so we threw it into the junk mail folder, or we thought it was something a little more nefarious, so we quarantined the message. When it comes to false negatives and false positives, managing those, dealing with those is one of the top call and top ticket creators we have for Microsoft 365 today.
So, but is that, Paul, because it's so complex and complicated to detect the right way, or is it misconfiguration, or what's the problem with those false positives and false negatives?
Honestly, a little bit of everything. But many of the calls that we get, many of the tickets we get, as it relates to false negatives, are self-imposed by putting in what we call overrides, and many false positives are due to a lack of email authentication set up with the sending organization. Not necessarily through anything you as the recipient had done, but that sender doesn't have their authentication resources either set up properly or even set up at all. I do see occasionally some organizations simply don't have them set up.
So, and when we talked about the show, it was a lot about authentications and lots of acronyms that you throw around you, and so I think, is that something we want to start with and
I
have a look
think
at
that's the
what are the?
best.
Okay,
Yeah.
so
Yeah, I
let's
think that's the
dive
best way
into
to
the
start it.
complex world.
Absolutely. So we'll start off talking about email authentication and how that can have an impact on messages coming into your organization and how they might be recognized as false positives. There are 4 email authentication types in use by Exchange Online Protection, or EOP, today. And they are SPF, which stands for Sender Policy Framework, DKIM, which stands for Domain Keys Identified Mail, DMARC, which is Domain-Based Message Authentication, Reporting, and Conformance. And then the final one is ARC, which stands for Authenticated Received Chain.
So, quick question: are these all standard protocols used by anyone, or is that something Microsoft specific?
These are all industry standard. They are all RFC based. Um, and any good mail service provider, mail security provider should be able to either stamp the messages as expected, send from sources required, and read the contents from the message and make determinations based on that sending organization's email authentication practices.
So, the first one you mentioned was something with S. Let's start with that.
Yes, Sender Policy Framework, or SPF. The way SPF works, and it's a pretty simple thing to configure, is as someone is receiving a message that is associated with your email domain, that recipient is going to do a lookup for an SPF record for your domain and verify that the message is coming from an IP address that is listed on that SPF record. SPF records are super simple. You create the record. It is a text-based record, and it will have different lookups, either based on an IP address or based on a host name. And there is also a brief note on what to do with a message should it not align properly with that record.
And that's something that you do in your domain name system?
That is correct. Yes. So you would create a TXT record, and at the after we get through all of the protocols, I will hop into CMD and I will show you examples of all of these records against the Microsoft domain.
Okay, cool. Can we do that?
Of course
Okay.
we can. It's public. It's all internet based, and anybody who would receive an email from me at Microsoft would be looking at that anyway. So,
Okay,
yep,
good.
yep. Um, there are a couple caveats though with SPF. It's not an end all be all. The first big caveat is that when you receive an email, it's actually, there's 2 from addresses on there. One address is what we call the P1 address, which is also known as the RFC 5321 address, or the 5321 mail from, or the envelope from. Um, that's the address that's used at the beginning of the SMTP um, transaction. That's what's used at the beginning to establish that communication with the recipient server. The SPF record will line up with that sending address. However, the address that you see in your email client, that is the P2 sender.
What
So
is
that
P1 and P2? You lost me already. I promised everyone it's complex.
so there's the 2 different addresses. The one is really used in the transmission phase during the protocol, and then the other one is introduced during the actual header, during the actual transmission of the data. So when you open up your email client and you see "from Paul," that's actually my P2 address. That address is also called the RFC 5322 header from address. So as you can see, there's a bit of a disconnect here in that the sender's IP address could be associated with one domain, and that SPF record lookup could pass, but the detail in the P2 address could be spoofing somebody completely different.
So how would someone compare these? Is it like someone clicks, like how would I see this? Or is this just an email server thingy that they could see?
Effectively, it's really just the email server communication
Okay.
piece.
Okay.
By and large, for you as a user, it doesn't really matter. If you so desire to look that information up, you can hop into the headers of the email and you can see where the message is originating from, the original sender. The return path is one of the other addresses, and most of the time that aligns with the P1 sender. So we talked about how the P1 and the P2 can impact here, and that a malicious actor can set up their own domain, they can use their own P1 address, they can pass SPF because of that. And then the other potential caveat here is there's no true method to say what to do with a message if it fails SPF. There are what we call soft fail and a hard fail. And a hard fail should be taken by the recipient's mail system and either treated as junk or treated as bad and throw it into quarantine. And then a soft fail is literally just, oh, hey, this could be bad. So do with it as you will. But no one seems to really follow any strict sort of guidelines for either a hard fail or a soft fail. And it's really up to the recipient mail service as to what they want to do with it.
So what should they do for soft and hard fails?
Well, the recommendation would be to use a hard fail. Hard fail is going to be recognized by most recipients' mail servers as bad, right? So if I send a message to you and that IP address does not match the
Expected
sending
one.
architecture as specified in that SPF record, if your SPF record has a hard fail in there, then your receiving server should go ahead and mark it as a bad message and ensure that it doesn't get to you.
Okay, cool. Thank you.
Next up, we'll get to DKIM. And again, DKIM stands for Domain Keys Identified Mail. And this is an interesting specification because it helps confirm the legitimacy of the sending server and the legitimacy of the message itself. And the way that works is by utilizing public key cryptography, and the sending server is going to have the private key, and the public key they are going to make available in another text DNS record. When I send the message, I am going to review the details of the message, and I'm going to use my private key to stamp a signature in that message right into the DKIM header of the message, along with a hash that when your mail recipient server receives it, that server should be able to take the public key that it's able to look up from DNS, from my domain. It should be able to take that key along with the hash and recompute it, and the two signatures should match.
Okay.
If those signatures don't match, then we know that the message was tampered with during mail flow.
And then it won't accept the email.
Well, and that kind of depends too here. It's going to depend on the recipient server. If the recipient server wants to receive it and they want to say, hey, something's fishy, pun intended, then they'll either quarantine it or block it or junk it or what have you. It just really kind of depends on the recipient server in and of itself, which does lead me to the couple of caveats with DKIM in and of itself. The first one is that the signature does not need to be aligned to the sending person. So the signature that's being stamped is based on the sending server infrastructure and that private key. It doesn't necessarily have to be in that scenario again that I was talking about previously, where a P1 and a P2 header, where the addresses don't necessarily match up with the SPF record. Same thing as exists here. All we know is that message was signed by the sending server, but was it really signed on behalf of the person? That we don't necessarily know.
How can you change that?
Well, we'll get to that one in a minute. The other concern here is that the signatures can be broken. The signatures can be broken if you have a separate mail server, a mail security service, what have you, in front of Microsoft 365, and that third-party service could be checking the security of the message. It could be stamping in maybe a
disclaimer.
Yeah, a disclaimer or a reminder that says, hey, this message came from the outside. Oh, hey, this message was found to contain whatever. Or if they rewrite the URLs to a safety check service, any of these sort of things can and will break that DKIM signature because the signature that is in that message header does not match what we have now been able to compute on our own.
Okay. So, but I mean, I guess it's pretty common that there is maybe a third party, something outside that does these kind of things and mark and stamp and disclaim or whatever.
Yeah, there's plenty of third-party services that do that, including, Exchange Online Protection, EOP, and Defender for Office 365. So what can we do to not have that be a problem? Well, that leads me into the next email authentication protocol or email authentication standard, and that is DMARC, which is Domain-Based Message Authentication Reporting and Conformance. And what this does is it tries to help tie together a sender to SPF details and to DKIM. And this is yet another text-based DNS service where we're going to look up details about the domain that is supposedly sending this message. And we are going to check for alignment of the message to either SPF or DKIM. And provided the alignment checks pass, we're going to go ahead and we are going to deliver the message, provided there's nothing negative in the message. But from an email authentication standpoint, provided the alignment passes, the message can be queued for delivery. If the alignment fails, that's where DMARC actually has a say in the matter, and DMARC can tell the recipient to either reject the message or quarantine the message or to simply proceed as normal.
So you said something like DMARC needs to align. Like, how does that work?
Yes. So in order for a message to pass DMARC and be aligned, it needs to align with either SPF or to DKIM. And in order to do that with SPF, the server that is sending the message needs to be on the SPF record. And in addition to that, the P1 and the P2 domains need to match. So now we can get back to the idea of that whole P1 and P2 not matching. Well, it's a little less scary now, right? Okay. And then from a DKIM perspective, the way DKIM needs to be aligned is it needs to be signed, and the D equals tag inside of the DKIM header needs to match the domain of the P2 address, of that P2 sender address. So sending a message from paul@contoso.com, the D equals tag in that DKIM needs to be contoso.com.
So, and then we are asking customers to set up all of these. Correct.
We would like to see the customers have their SPF, their DKIM, and their DMARC configured. The main thing here for today's discussion, though, is that incoming messages. We would hope to see that anybody who is sending messages into you would be utilizing this as well. But if they're not, that's where you can potentially see some of those false positives, like I was talking about earlier.
Okay.
And working with some of those if they are trusted vendors, to make sure that they have that stuff in place. Well, that'll help with that.
Okay. So we talked about 4. Are we done with the third? Are we moving to the 4th? Or you want to talk about some caveats?
Well, before I get to the 4th, I wanted to see if you'd like to see some examples.
Of
of
course.
all right, so I'm going to start off with a couple of slides here to show you. First off is the sender policy framework limitations that I noted earlier. Here you can see that this is the P1 address. This is the address that's being used during the transmission of the message. And we see it's coming from Joe at IamAspoofer.com. If we look up the SPF record for IamAspoofer.com, the sending server is probably going to match. So provided the SPF record matches what the spoofer is trying to do, they're going to pass, even though here we see that the message is coming from Joe at Contosa.com. So in this scenario, even though we've passed SPF, we could be sending in a bad message. Now, there is a note here at the bottom that this could be legitimate. There are scenarios where maybe you are working with a third-party service, maybe an HR system, maybe a ticketing system, something that needs to send messages on your behalf, on your organization's behalf, and something like this might be required. But when it comes to the general use of email authentication, there are better ways to do this than to just let another company completely spoof you.
Wow. Okay. So now finally I see that coming together, the
Very
P1 and
good.
the P2. Awesome.
Yes,
Thank you.
sure. Now, when we think about DMARC and how it's used to check SPF, first we're going to check and see if the IP address is listed in that SPF record. And in this case here, we do see that SPF passes. The message being sent from 10.1.1.1 is approved for sending from example.com. And then we're going to check to make sure that the return path domain and the P2 domain match. So right here at the top, this is the original sending, the P1, and then this is the header this is the P2. So both of these align, we're good to go. Now, if we think about a scenario where SPF fails a DMARC check, we're going to see if the IP address is in that SPF record, which, yeah, it is. But we're also going to check to make sure that the domains match. And in this case, they do not. We do see that the original mail from address here, the P1, is fisher.com, which matches the SPF, but the header from does not. So this message doesn't align, thus it would not pass DMARC.
I feel like pushed back in my CSS times, customer service and support, where you were like always looking at these things.
Absolutely. Absolutely.
So, but this is not yet telling us that something is not configured the right way. This is just explaining how the checks are and how DMARC makes sure that SPF is
Correct.
worse. Yeah,
Correct.
okay.
Yes. So next up, we're going to check with DKIM. And we're going to check to see that DKIM, that the body hash is verified appropriately. And yes, it was. We were able to verify that detail. And now we're also going to check to make sure that the sender domain aligns with the DKIM domain. And here we see that D equals example.com and the sending address of postmaster at example.com align. So this message passes. Now, as far as a message that wouldn't pass, now we're going to look at the DKIM hash again, and we're going to see that the DKIM hash does pass. But
Not the domains. I can see it.
you've already found it. There you go.
Yes.
So here we see that the D value inside of that DKIM header is fisher.com, but the from address is actually example.com. So this does not align, thus it does not pass. And just to give you a little bit of a practical example here, I am going to bring over my PowerShell window here, and I'm going to show you some details for Microsoft. So Microsoft.com, the TXT record at the very bottom, this is our SPF record. So as a message is being received by somebody from Microsoft.com, it's going to go ahead and query this SPF record, and we're going to look at the details of all of these include statements to check to see that the sending IP address is on one of these lists. And if so, great. we'll go ahead and we'll send it on through to the next step. If not, we'll go ahead and mark it as a hard fail, which again should be considered bad by the recipient. And now the next one I want to show here, this is a DKIM record again for Microsoft, and this is one that I had seen in a message that I had sent. It was set up to use selector 2, and this is what is utilized by the S equals tag inside of the DKIM header. And here we see that the P equals value on this is the public key. So if I were to send a message as Microsoft.com to a recipient, that recipient would query from the selector information and the domain to query the information about this public key, and then go ahead and try to decrypt the signature, try to make sure that it matches the signature that was received in the message originally. And then the
Okay.
final one here is DMARC. So DMARC is where we're going to tie it all together, right? So DMARC P equals reject. This is what we're saying to do with a message. This is policy equals reject. Any message that does not adhere to the DMARC, it doesn't align to our DMARC requirements here. We're also saying percentage equals 100. We're saying that we want to reject 100% of messages that fail alignment. And then you'll also notice here there are a couple of email addresses and a functionality, a reporting piece here. And again, this is the part that I'm not looking to get into here today, but these are the addresses to be used for the reporting and conformance piece of DMARC.
So we talked about 3 out of 4 protocols. Now it's time to unreal the last one.
Yes, yes. The last one is ARC, which stands for Authenticated Receive Chain. And it is really the new kid on the block when it comes to email authentication. But effectively, what ARC allows us to do is it allows the first line in an email recipient chain. So thinking of an example where someone might have a third party in front of EOP and Defender for Office 365, if they were to go ahead and implement ARC, they can take the initial email authentication results of a message, the SPF result, the DKIM, the DMARC, and they can take that detail and wrap it up and seal it in what's called an ARC sealer. And they can add that to a new header to the message that is then shipped along its way to us. And we can look at the detail in that ARC header and take action based on that ARC header instead of taking action based on the DKIM issue that might have popped up or an SPF issue that might pop up because it's coming from an IP address associated with that trusted mail service and not the original sender. This also helps to work around the use of what we call skip filtering or enhanced filtering for connectors, which is a very helpful thing to utilize in a scenario like this where you have defense in depth or you have another mail service in front of us for security. But that again, that only works for SPF. That only helps us look back at the original sending IPs for SPF. It doesn't help with any of the issues related to DMARC failures or invalid DKIM signatures due to updates in the messages or attachments or what have you.
So for the other 3 protocols, you always had the caveats.
Mm-hmm.
So I'm wondering if you have some anyways, even though it's the new kid, shiny new kid on the block.
Right, right. So the thing with ARC is that it's not necessarily a security. It's not really an email authentication piece related to security itself. It simply helps us preserve the details when there's maybe an intermediary in play. So no real security considerations there, just that it helps to utilize what we already know is good, or what we already know is true, I should say. The other concern is that not enough organizations are supporting it yet. So for organizations that do run defense in depth today, I'd recommend working with your first and your outer edge service, mail security service, to get ARC supported. We already sign messages with ARC, and there are a couple of others out there that do. But again, it's the support is few and far between.
Okay, so I think I have a last question, and I hope we can get this answered short because we're running a little bit out of time. So, but if email authentication helps prevent messages from being marked as bad, what happens without it?
Well, when a message is received by us and there is no email authentication detail associated with it, we're going to look at some additional detail about the message. We're going to look at heuristics of the message. We're going to look at all of the normal anti-spam, anti-phish, anti-malware type of things. But we're also going to look at the reputation of the sending IP address. We're going to look at the reputation of the domain. And we're going to take into account just a number of many different factors based on what we know, and make a distinction off of that. There are a lot of organizations who you might work with. There might be a lot of partners or trusted vendors or whomever who tell you, you know what, go ahead and add our IP addresses to that allowed IP list. Go ahead and add our domain to your trusted domain
Is
list.
this because they're lazy?
It might be. It might be. So there's one of two things here. They're either lazy and they don't have the email authentication pieces put in place, or they don't understand it, or they have legitimate concerns about the content that's in their messages. From a standpoint of false positives, email authentication should be good enough to work with legitimate email coming through. Working with that HR vendor, working with that alerting service, you shouldn't need to add their details into a safe sender list, and a safe IP list, an exchange transport rule. You shouldn't have to do that, because that is actually going to override most of the protection in our stack, which sets us up for next time, false negatives. And I think you might see where this is going next, huh?
Yeah. But before we get there, or before we close, it's a complex topic. It's a lot of things to configure, to consider. Is there a good resource that we can share where people, is that like a step-by-step guide or something? What do need, besides watching that episode over and over again, what do people need to do to understand and know how to configure these authentications?
So the pages that popped up while I was talking about SPF, DMARC, and DKIM, review those. Absolutely review those. And also review the parent article of those three items. They'll give you a good understanding of how email authentication works with Microsoft 365. And I'll also throw out that the Wikipedia articles on each of those, they're pretty solid. I mean, these are standard-based.
But they explain things but they don't show me what I need to do.
They have links to information on the original RFCs.
Okay.
And there are a number of really good third-party services out there to help explain maybe a little bit deeper, and how to best configure, particularly in scenarios that you might be a little more complex, where maybe you have a trusted vendor and you need to give them a key, things like that.
Okay. So Paul, for now, thank you so much. And I will see you soon again, because we need to continue with that, and we need to talk about false negatives. So thank you first of all, for being on the show. And thanks everyone for watching, and stay tuned when we continue with part 2 of this crazy title show.